Hello everyone, welcome to my channel Mathusiasm. Today we're going to solve this challenging radical equation. First of all, we have to get rid of the cube roots. So let's take cube on both sides. However, if we do it directly on the equation, the left-hand side is in the form of p plus q whole cube. We have to apply binomial theorem to expand it, which is p cubed plus 3p squared q plus 3pq squared plus q cubed. Applying the result, we get this complicated equation. Now we can see that the middle two terms still have the cube roots. We can't move on. So we have to take the power 3 in a nice way. How do we do that? Let's use a substitution. We let a equals to the cube root of 15 minus 3x, and b is equal to the cube root of 3x minus 15. So the equation is much better now. It's just a plus b is equal to 5. But the equation is changed from one unknown x to two unknowns a and b. What should we do? Now we're going to take a cube and b cube, which are simply 15 minus 3x and 3x minus 15. If we add them up, the 3x terms cancel out each other. It's just a constant, which is 35. So we set up two equations for two unknowns, which are a plus b is equal to 5 and a cubed plus b cubed is equal to 35. Label them as equations 1 and 2. As the second equation is sum of two cubes, we can apply the identity to factorize it. It's bracket a plus b times bracket a squared minus ab plus b squared. Let's call it equation 3. The first term is the sum of a and b, which is exactly 5. Put equation 1 into equation 3 and divide 5 on both sides. We'll have a squared minus ab plus b squared is equal to 7. Let's call it equation 4. So the cubic equation is reduced to quadratic. See, using two variables to solve equation actually makes it easier. Let's continue with the quadratic equation. From the sum of a and b, we get b is equal to 5 minus 8. Put it into equation 4, it becomes a squared minus a times 5 minus a plus 5 minus a whole square is equal to 7. To expand this term, we use the perfect square identity. X minus y whole square is equal to x squared minus 2xy plus y squared. So it's 25 minus 10a plus a squared. Simplify the equation, it becomes 3a squared minus 15a plus 18 is equal to 0. Divide the whole equation by 3 is further simplified to a squared minus 5a plus 6 is equal to 0. Now it's quite straightforward at this point, isn't it? To solve the quadratic equation, we can use cross method to factorize it. It's bracket a minus 2 times bracket a minus 3 is equal to 0. Therefore, a is 2 or 3. We put back a equals to the cube root of 15 minus 3x into the two equations. Taking power 3 on both sides, we have 15 minus 3x is equal to 8 or 27. Solving the two simple linear equations, we get the answers. X is equal to 14 or 23 over 3. Do you expect that a cube root equation has two real roots instead of 3? If you want to know more interesting problems in algebra, please check out the videos and the playlist shown on the screen and in the descriptions below. See you in the next video.